Hello my dear students, Assalamu alaikum. I welcome you again, and it's Eid Mubarak to all of you and to your family also. Today I'm going to talk about circular motion. Okay, circular motion. We have studied the one-dimensional motion till now. We have studied the one-dimensional motion, and now we will study the circular motion. It's a kind of motion whose path is a circular track. Okay, motion along a circular track is called a circular motion. Motion along a circular track. Okay, along a circular track is called circular motion. The motion which is along a circular track that is called a circular motion. For example, this is a circular track, and circle has got a constant radius. If this is a center, this is its this is diameter, and half of the diameter is radius. Okay, from this to this is r. Okay, this is r, and a circular has got a constant radius. This means that if the body moves in this path, in this circular path, and that motion will be called circular motion. And if an object moves on a circular path of constant radius, and this is a constant radius with uniform speed, okay, if the body is moving with uniform speed, that motion will be called uniform circular motion. Okay, uniform circular motion. If the body is moving with uniform speed, that motion will be called uniform circular motion. And if an object moving along a circular track with uniform speed is an example of uniformly accelerated motion. Okay, this is this concept has to be understood, that if an object moving along a circular track with uniform speed, okay, with uniform speed, it's an example of uniformly accelerated motion. How is this possible that this is an example of accelerated motion? We have studied that if the body has uniform speed, and that will not be uniformly accelerated motion, but that is the case of one-dimensional motion. If the body is moving in one-dimensional motion, and if it has got uniform speed, we will say that the body is not accelerated. The body moves equal distance in equal interval of time. That means the speed is constant, and if the speed is constant, that means the body is not accelerating. But here the case is different. If the body is moving along this track, along the circular track with uniform speed, this is the example of uniformly accelerated motion. How is this possible? This is possible because the body changes its direction every time. Okay, the body changes its direction every time. This means that if the direction is changed, that motion will be accelerated motion. That motion will be accelerated motion, and we have studied that if the direction of the body changes, that means velocity will also be changed. And if the velocity is changed, that means that is an accelerated motion. So here the case is that the body changes its direction every time. Okay, and if the body changes its direction every time, so velocity will not be constant. Velocity will be different at every point, and this means that this motion will be accelerated motion. Okay, this will be accelerated motion. The velocity of the body at any point on the circular path is along a tangent. If we have to find the velocity here in the circular path, how can we find the velocity? We can find the velocity by drawing a tangent. Okay, by drawing a tangent. For example, body is here. For example, body is at this point. How can we find the velocity? We can find the velocity by drawing a tangent over it. Okay, if this was a tangent, and this tangent gives the direction of the velocity. Okay, this gives the direction of the velocity. That means at this point, the direction of the velocity is towards this side. If the body is here, for example, if a body is here, we will draw here a tangent. Okay, we'll draw here a tangent, and this tangent shows the direction of the velocity. That means the direction is towards this side. If the body is here, okay, we will draw a tangent here. This means that that the direction of the body is towards this side, okay, downwards, and so on. Similarly, if the body is here, we will draw a tangent here. This show the direction of the velocity. If the body is moving in this direction, okay, in this direction like this, we will draw a tangent, and this arrowhead shows that the body is moving like in this clockwise direction. Okay, clockwise direction. And similarly, if the body is here moving in clockwise direction, we will draw a tangent here. This tangent will give the direction of the velocity. If the body is here, we will draw a tangent here. This tangent will give the direction of the velocity. Let me show here with the diagram that how the direction of the velocity gets changed every time. For example, if an athlete runs around a circular path, okay, if it runs around a square track, for example, this is a square track. For example, if the athlete rounds in this track, in the circular track, this means that he is changing its speed. He is changing his speed at 4 times. Okay, here the direction is changed. This means that velocity is changing. Here also the direction is changed, and this means the velocity is changed. And here also, and here also, this means that the athlete changes his velocity 4 times. Similarly, if he runs in a hexagonal path, for example, this is a hexagonal path. If he runs in this path, here he changes his direction 6 times. Okay, 1, 2, 3, 4, 5, 6. He changes his direction 6 times. And similarly, if it's a octagonal shaped, okay, octagonal shaped having 8 sides, and there the athlete will change his direction 8 times. Okay, and if we increase the sides, that means if we got a polygon, if the track was a polygon like this, okay, if this was a polygon, this means that the athlete will change its direction many a times. For example, here, 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 here also, here also, here also, here also. The athlete will change his direction many a times. And if we go on increasing the sides of this polygon, we will get a track. We will get a track which is like this. Okay, which is like this. And here the body will change its direction at every point. The body will change its direction at every point. So you may call it as uniform circular motion. You may call it as uniform circular motion, or you may call it uniformly accelerated motion. Okay, uniformly accelerated motion. If this is a circular track and it has got a constant radius, but the direction here changes continuously. The direction changes continuously. This means that velocity gets changed. Velocity gets changed. If the velocity gets changed, this is uniformly. This is accelerated motion. Okay, this is accelerated motion. But here the acceleration acts toward the center of the circular path. Okay, the acceleration acts toward the center of the circular path. This means that here is a special type of force which is dragging the object here towards its center, which bounds the object to move in the circular track. If the velocity gets greater, that velocity will be called escape velocity. That means if the object did not remain in the circular path, if the object does not remain in the circular path and moves away from this circular path, that velocity will be called escape velocity, because that from that velocity the body will not remain its circular path until the body remains its this circular path. This means that a special type of force is acting towards the center, and that type of force is called centripetal force. Okay, that's called a centripetal force. And this type of acceleration, which when the body is moving along the circular track and the body has got some acceleration, and that type of acceleration is called a centripetal acceleration. Okay, centripetal acceleration. Here we know that circular motion is thus a very interesting case of uniform motion. Okay, it's a uniform motion, but it is also an accelerated motion. Accelerated uniform motion because due to constant speed. If it has got a constant speed, that means the body is moving in a constant speed. But at the same time, it is accelerated also. Accelerated because of changing velocity. Okay, because it changes the direction, it gets change in velocity. So this is a special type of what we call a motion, special type of motion. And uniform circular motion is therefore an accelerated motion. So this is an accelerated motion here.